How does sphere surface area, π squared, relate to for circles? Imagine holding a perfect sphere and then thinking about its surface. Now picture for circles, each with the same radius as the sphere. How are they connected? Let's find out. The surface area of a sphere is calculated using the formula for times pi times the radius squared. That is for pi r squared. Pi is about 3.14, and the radius is the distance from the center to the edge of the sphere. This formula tells us how much space the outer surface of the sphere covers. Now think about a single circle. Its area is pi r squared. That's the size of a flat, round shape with the same radius as the sphere. If you take 4 of these circles and add their areas together, you get 4 times pi r squared. That's exactly the same as the surface area of the sphere. So, the surface area of a sphere can be seen as the combined area of 4 circles, each with the same radius. This makes the idea easier to understand because it links a 3-dimensional shape to a familiar 2-dimensional shape. Instead of imagining a curved surface, you can think of it as 4 flat circles stacked together. Why does this work? When a sphere is created by rotating a semicircle around its diameter, the total surface area results from this rotation. Mathematically, this process shows that the surface area is 4 times the area of the circle that forms the cross-section. This connection was proven through calculus and geometric reasoning long ago. In practical terms, if you could flatten the surface of a sphere without stretching or tearing it, the total area would be equal to 4 circles of the same radius. This helps us see how the surface area grows as the radius increases. It grows proportionally to the square of the radius, just like the area of a circle. This relationship is used in many real-world applications. For example, calculating the surface area of planets, bubbles, or any round object. It also helps us understand how the size of the sphere affects its surface. The larger the radius, the bigger the surface area, just like the 4 circles combined. In summary, the formula for the surface area of a sphere, for pi r squared, relates directly to 4 circles of radius r because the total surface area equals the combined area of those 4 circles. This connection makes it easier to visualize and understand how the surface of a sphere is measured and why it grows with the square of the radius.